Thank you everyone for joining us again. I will now welcome Dr. A. Mukherjee, former scientist, CGWB, Government of India. I request Ms. Deepika to formally welcome him with saplings. Welcome, sir. Now I invite sir to deliver an expert lecture on prevalence, fate, toxicity and management of arsenic in groundwater.
A very good morning to all of you, and I am thankful to the organizer, Professor Singh and Dr. Anil, who is one of my friend. We know each other for a long period, and as I know, the Delhi Technology University, particularly the Environmental Center, is working very good on environmental aspect, and when there is scientists like Professor Singh and Professor Anil, it will work good for the society, and I am happy to hear and thankful to the organizer for giving me the chance. The subject today has been selected bit, I can say bit specific and technical. The audience here may get some, it is bit deeper in the science, but definitely not out of the context. Actually, India is one of the country globally where groundwater is being extracted highest. So we are the #1 extractor of groundwater, and the tune of the groundwater extraction is that both China and USA together is not extracting half what we are extracting from groundwater. That is the comparison. Since the Southeast Asian countries, including India, Bangladesh, Pakistan, Nepal, Sri Lanka, together is extracting more than 70% of the total abstraction of groundwater. So, this year's topic of World Water Day, groundwater, a invisible resource and visible impact, is very much apt for our country, India, and specifically for the Southeast Asian countries, where groundwater-based civilization is proliferating. Earlier, our civilization started with river valleys, but slowly when the population density grown, we have migrated from the river valleys to the plain land, and now we have even migrated to hilly areas. So there, the groundwater is the principal source of perennial water. When I say perennial water, that is water which is available throughout the year to us. All the principal source of water is the rainwater, of course, but in Indian condition, rainwater occurs only around 60, 65 to 70 days at the most, anywhere if you take in the country, and it is reducing day by day. None other than Mr. Nigam can verify this fact that rainy days are shrinking a lot. Earlier in Delhi NCR area, the rainy days were around 35 to 40, but now it has sunk to 25 days. But the thing is that though the rainy days has sunk, but the quantum of the rainfall has not gone down. So what happened? Within the 25 days, all the water which are earlier coming in 40 days or 35 days are now coming in 25 days. So intensity has gone up, and due to the pavement of the surface and due to this higher intensity, the groundwater recharge, which is the natural process, is reducing day by day. When there is a high intensity in short period, the upper layer gets saturated fast and no further groundwater, percolation of water to groundwater table occurs. So these are the situation which is occurring due to the climatic condition. But the human intervention, or say I can say anthropogenic impact, is also very, very sharp. Due to the high intensity of population in this area, we are making the surface paved more and more. And with the paving, there is a little area to go the rain naturally inside. So all of these has caused many things. But what today's topic is the arsenic in groundwater. So I'll come with that. In this particular slide, I can show you that there are certain parameters which actually affect the human being most. And these parameters are salinity, fluoride, nitrate, arsenic. In these 4 parameters, only the nitrate is due to the only cause due to anthropogenic source. When I say anthropogenic, means all living beings contribute for that. Rest all the things, salinity, fluoride and arsenic, these can be caused both by geogenic and anthropogenic cause. But the salinity, fluoride and arsenic in groundwater is largely for the geogenic cause. So when that is a geogenic cause, so it has a limitation for the mankind to remove this from the system. But there are anthropogenic activity which induce these enhanced content of these pollutant. As you can see that salinity in 212 district, fluoride in 334 district, nitrate in 387 district and arsenic in 154 districts of India covering this pollution in groundwater. Still I can tell you, still the groundwater in our country is potable in nature. But think the day, due to anthropogenic condition, if we make all the groundwater polluted, then each groundwater abstraction need purification or treatment. Once that condition comes, then the cost of water will go from this to this. But since we are still getting groundwater in the potable condition, we just extract from ground and use it as it is. Though in urban areas, we are using domestic water purification conditions. But these domestic water purification conditions are available to certain category or certain class of people only. But the general mass doesn't get the privilege of getting these because these are very expensive. So arsenic, as you know, is a semi-metal in condition. When it gets dissolved in water, particularly groundwater, it doesn't create any color, taste or smell. So as such, drinking water also have no color, no taste, no smell. If these 3 criteria happens, then only we first consider a water as a drinking water. If there is a color, if there is a smell, or if there is any taste, then we don't consider that water a perfect drinking water. Remaining pollutant analyze we later. First we see these things. And contamination of arsenic doesn't change the basic property of water by adding this. And what is the concentration of arsenic which get toxicity to the water? It is 0.01 ppm. What is 0.01 ppm? It is ppm and milligram is the same. So 0.01 milligram per liter. If that much concentration is available in water, that is toxic for human being. And this standard has been derived for the European standard, where average drinking water consumption per day is around 2 to 3 liter, where in the European country the water intake is less because of the climatic condition. In tropical condition like India, our average intake of water as a drinking water raised to 4 liter around. So, though we follow the BIS, also follow WHO standard of 10 ppb, but 10 ppb is permissible for 2 liter consumption. We are still not very much following that. But again, with arsenic there is a fortune involved, because all the sources within an arsenic contaminated area are not always polluted. So it has been found that nearly 50% or 55% wells are in general polluted in a arsenic contaminated area. Remaining 40% or around are not that polluted. So if you able to pick those wells, even you can have arsenic free water. Another thing, our traditional Indian conditions are having sanitary dug wells. Earlier days in India, we are having dug wells, कुआं जिसको बोलते हैं हिंदी में. Those dug wells are large in dia and little in depth. Maximum depth is 10 meter. So those large dug wells, which are always in contact with the atmosphere, has the potential to precipitate maximum the toxic element. Still nowadays, if you have dug well water, that is less polluted in arsenic in compared to any hand pump, tube well or so. But what happened? Due to our faulty sewerage system and our mismanagement of solid and liquid waste, we have contaminated all our dug well zone. And those dug well zones are now polluted with pathogens and likewise things which gives us seasonal illness. But when you alternatively, when you gone to the deeper zone, the atmosphere there in the deeper zone is contaminated with the toxic element which gives us chronic diseases. I don't suggest you to go back to the dug well zone, but if possible, if you able to create such environment for your dug well zone, still within that arsenic advisory zone, you can have good water in dug wells. If you see the list here, 21 of the state has already found contaminated with arsenic poisoning or toxicity, that is more than 0.01 milligram per liter in water. And these include 154 districts. Ganga river basin is one of the most fertile and densely populated area in the world, and its inhabitants rely directly or indirectly on the basin water for food and agriculture. Ganga river basin, which encompasses significant geographical portion of India, Bangladesh, Nepal and Tibet, exhibits elevated level of arsenic in groundwater. So if you see, it is more than 4,700 microgram per liter in drinking water, more than 1,000 microgram in agriculture water or irrigation water, and even in the food material more than 3,900 milligram per kg has been identified by various researchers, and one of our globally recognized researcher is from Jadavpur University, Mr. Dipankar Chakravarti. He is a pioneer in Indian arsenic research from Jadavpur University of Environment Science. They have identified these data, and they are working for last, say, 83 onwards, all exceeding the WHO standard for drinking water, United States National Food and Agriculture Organization standard for irrigation water, and Chinese Ministry of Health and Health standard for food and South Asia. These, if you see the map, this map, you can see as the Ganga is the largest river basin, and it comes from your Himalaya and flows towards your eastern side and goes to Bay of Bengal. So all along the Ganga, all the red dots, these are the area where elevated arsenic in groundwater has been noticed. It extends to Bangladesh, it extends to Pakistan, it extends to Nepal. So that this is the globally the worst groundwater hazard identified in our area, and affecting 30 million population. Apart from this, in the hard rock terrain of country, in Chhattisgarh and Karnataka, there are patchy occurrence of arsenic, which is geologically different from the Ganga basin's arsenic contamination. Two things I have already mentioned you, that high degree of spatial variability. What is spatial variability? Means one place, another place, another place, it is highly variable. Then verticality, there is a depth restriction. So it has found by studies that these arsenic contamination are vertically restricted to shallower 100 meter. But again, it is contradictory with the dug well, what I have told. But dug well, below dug well zone, which is not in direct contact, up to that, from that to up to 100 meter depth, all these area are severely contaminated. But in those areas, deeper levels are still arsenic free. So these are some examples what happens. It's very pathetic condition. Actually, doctors themselves says that yet the entire diagnosis of arsenic related health hazard has not been described properly. There are so many cases because it is a complex situation. Therefore, exactly they cannot say, but they have identified few particular things which I will explain, include the arsenic manifestation on the health. These manifestation when comes to young age, that means already arsenic has damaged your internal organ. So manifestation is not the beginning. Manifestation is your stage of health. So red patches developed on early days, but it is found very well that good nutrition in childhood can restrict health impact of arsenic to some extent. Therefore, in those areas where the arsenic contamination is there, malnutrition has to be controlled very much, and midday meal program can be very useful with high protein content. So now see, where is your midday meal program? Where is your arsenic research? But you can correlate both these things. So the science as a holistic science required. We are unfortunate in many time that we are not doing holistic science. In shallow we do research, but malnutrition can be mitigated through your midday meal program, and in midday meal program all our school teachers are very much the soldier for this kind of arsenic related problem mitigation. So these are some different kind of diseases which includes your toxicity of in human. You can see these hands and foot portion is first exposed, which can be very well visible in the villagers and citizen. The contamination in Bengal Basin has come one of the extensive studied issue in world and regarded as the severest case of health hazard in the history of mankind. Numerous arsenic-induced death of young people, victims are reported in Ganga River Basin. Victims of arsenic exposure face critical social challenge in the form of social isolation. It is not only the health hazard, it has a social impact also. हम पहले सुनते थे जिनको लेप्रेसी होता है, लेप्रेसी patients were socially isolated. Now these arsenic affected people are facing the same kind of thing because leprosy more or less has been now controlled within our country. But these are the new patient who gets this kind of social isolation, and the people sitting here, they don't understand what is social isolation. It is such a pathetic, even death is better thing. So the appearance of skin lesion is a red flag, as there are manifestation of severe internal damage. As I have already told you, this red flags within the skin are not the first indication, but serious indication of serious damage. The irony is that to date, no known medicine can cure chronic arsenic toxicity. There is no medicine as such for cure of arsenic, chronic arsenic poisoning. So only arsenic safe water and nutritious food, including vitamins, are suggested as preventive measures. So there is a saying that prevention is better than cure, so that is here. For arsenic case, prevent the patient from arsenic toxicity. Elevated concentration of arsenic in groundwater has been observed in gray and dark gray sediments of Holocene age, that is newer alluvium, deposited in the fluvio-lacustrine environment in the floodplain of Ganga and most of its northern tributary from Himalaya. Those who know the geography and the Ganga basin, all our rivers come from Himalaya and join the east flowing Ganga. So this is the east-west line, there are north-south line, the north-south line joins to east-west line, and finally it flows to, so all along that you have seen the arsenic. And Holocene age is something 10-15,000 year only. So last 10-15,000 year age sediment has the maximum arsenic concentration. So if you avoid those sediments and go beyond that, there is a much more chances of getting less arsenic contamination in this. So knowledge of geography, knowledge of geology is way to prevent from arsenic toxicity. There are so many engineering solutions to arsenic mitigation. But those all engineering solution, some way or other has some limitation. So best way to eliminate those sources. So if you able to do that, it has a much more wider scope of elimination of the toxicity than your engineering source. Mobilization process. Yes, some student may be interested in mobilization process. What happens? Why the river water are less arsenic contaminated than groundwater? Why dug well zones are less polluted than hand pump or tube well zones? There is a mechanism, and these mechanisms are induced by the microbial processes. First, what happens? The reductive dissolution of iron hydroxide coating. The iron hydroxide coating occurs around the sediment grains. And these iron hydroxides adsorb your arsenic molecule which released from the sediment. And once it adsorbs, it becomes a secondary source. And once the atmosphere get in the reducing condition, these hydroxy coating, iron hydroxy coating get dissolved due to EH-pH condition, and once it's dissolved, then the adsorbed arsenic get released, and the microbial process help in this. The area is marked with shallow water level less than 8 meter below ground level with ample monsoon recharge. Those areas are more prone to arsenic contamination. Infiltrated rainwater and percolating water from surface water body carry organic carbon from sediment. This organic carbon help these microbiological processes which do this kind of increase microbiological process. So the diagram is here, the conceptual model, where you can see the oxidizing and reducing condition. And as I had told you, once the water get in the reducing condition and this hydroxyl coating of sediment gets dissolved and microbiological processes release the arsenic, and from solid phase to it comes to the aqueous phase. And once it comes to aqueous phase, and that water when you take chronically, it is not that if once you take arsenic water you will be having some health hazard, but it is the chronic, those natives who stay there and drink that water each and every day, they are get affected. Not that if you visit once in some village which is arsenic affected, you just drink water and you will get arsenic affected. Not like that. It is not that. Arsenicum is a medicine in homeopathy. So arsenic is having a medicinal value, but in a controlled way. But when you take that medicine each day, each time, then it gets a toxic effect. So in India, as I told you, in 1983, the arsenic poisoning was first reported in the state of West Bengal by School of Environmental Studies, Jadavpur University, Calcutta. Simultaneously in 92, the Bangladesh arsenic poisoning was reported, and in 99, the Nepal the arsenic poisoning has reported. So if you see, basically last 2-3 decades is the main time when the arsenic poisoning has been reported largely. If you want to correlate these things, then you find that yes, these are 4 or 5 decades back we started using the deeper well. Once you started using the deeper well and the arsenic poisoning cases raised suddenly in quantity, and manifestation of arsenic thing took some 10 years, and that has been reported in 80s. So there is a direct correlation between the drinking water's abstraction and the arsenic poisoning. So these are the state and the district where I will not read all these things. Those who are interested can take this PPT. So if you see this particular graph, you will find that as deep you go, the arsenic concentration in the x-axis, the concentration, and in the y-axis, you have the depth. As you go the deeper and deeper, the arsenic concentration goes low and low. So deeper portion, if you see the deeper portion here, have only 1 to 10 ppb. But in the shallower portion, even if you are getting 1000 ppb. So that kind of correlation shows that if you go in for shallow tube wells for drinking water supply, that will have your worst effect. So why the Himalaya is being blamed? It is having the geological or tectonic linkage to this arsenic release from Himalaya, because all the river of Ganga system brings sediments from Himalaya, and release of these sediments is related to your tectonism. So neotectonism, due to neotectonism or due to rise of Himalaya between the collision of Indian plate to your Tibetan plate, there is a collision between Indian plate moved north and northeastern side and collided with the Tibetan plate, and in between there was the Tethys Sea, and that has shrinked and all the sediment formed your Himalaya. So that started around 300 billion years ago. So from that time onwards, this rise of Himalaya started, and now this rise of Himalaya has the main source of your arsenic related mineralization in the sediment. And those sediment later on, due to geomorphological condition, has brought to Ganga basin, and that's Ganga basin sediments. I'm not going a very detail or deep because I know that much of you are not the student of geology. So then what are the mitigation strategy? Central Groundwater Board, being the nodal agency of groundwater in the country, has started exploring the way out from the arsenic contamination. And they have initially able to see there is a depth restriction of the water arsenic. So they have constructed some 283 exploratory well, means say establishing 283 workstation. They have established 283 workstation in various parts of the country to study the arsenic and its mitigation strategy or how it is behaved, in collaboration with, of course, institute like yours or some other national repute. So in West Bengal, the 100-meter BGL is arseniferous, 120 to 160 and 200 to 250 aquifer zone occurring below the ground level are arsenic free. The top arseniferous aquifer is separated from deeper aquifer by thick clay. 179 well constructed and arsenic free wells in arsenic free aquifer have been handed over, etc., etc. So these are the 3D geological section with hydrogeological input. So what we call nowadays a aquifer mapping. So these aquifer mapping, Central Groundwater Board is doing from last 1970 onwards. But terminology has now been changed, and now we call it in more sophisticated way that aquifer mapping. So these kind of 3D sections where which zone, what condition, in which area, which aquifer is separated by clays. Aquifers are important for getting water, no doubt about it. But without aquiclude or aquitard, aquifer has no meaning. It will be like a glass without the base. If you have a glass without base, there will be no water. So those aquiclude or aquitards are the base to that glass. And now, not only for the water, for the toxicity also. Those base restrict your top pollution to go below, or from the below pollution to top. So those aquitard, it is very unfortunate when the researches are going on, everybody is after aquifer. Nobody want to study aquitard or aquiclude in that depth. Why? Without aquitard or aquiclude, can you able to survive your aquifers? So researches, you people are there, you can do research on aquitard, behavior of aquitard and aquicludes, so that they produce immense, though the aquitard and aquicludes are like the support staff behind your institution, the front staff of your HOD and faculty. But there are so many other who give the shape to this institution. Without them, will your HOD and faculty able to run this organization? It will not. But in our system, many a time we overlook the overall contribution of the resource which give us this kind of good atmosphere for teaching. Similarly, the entire system, the aquitard and aquifers are to be studied together holistically. Like that, in Bihar, 120-meter zone is found contaminated with arsenic, and 140 to 250 meter below, those are free. Dug wells as a safe drinking water source in arsenic affected habitation in the alluvial floodplain in North Bihar. Make Pani Abhiyan is a NGO. They are promoting this very, very basic science to each and every villagers. Make your sanitary dug wells free from biological contamination, and that will be more eco-friendly and more health friendly. And this is having no engineering involved. These are the natural things. So though no maintenance, low maintenance. So these kind of interventions are required. These are the sections where we do research. Take an example of Gazipur, that is in the eastern UP, just outskirt of your Bihar. Just taking example how the arsenic is distributed. See all the red dots and your violet dots. You will find that all red dot and violet dots are more or less concentrated on and around the Ganga. Why? I have told you in previous slide, these are the Holocene sediment which are more responsible for arsenic migration or transport. So, where this Holocene sediment or newer alluvial occurs, it occurs within the active floodplain or the terrace of the river. So, river morphology, study of river morphology, a good geomorphologist can give you a good site for arsenic free well. So these are the holistic approach. It is not the groundwater scientists only can give you good site. It is the good geomorphologist can give you good site. Similarly, these are some. Now, these are the well design. What happens? The construction of well is a very, very neglected subject in our country. Just we want to know that yes, put some well and go up to the aquifer and dig water. That can be good for area where there is no contamination or there is no scope of contamination. But in area where there is a chance of contamination from top or bottom, the well designing are very, very important, and this subject is very much within the purview of the environmental engineering, and those who want to make their career in this subject should come out with a very good alternative, cheap and sustainable well design, so that can serve for longer period. Even in the Brahmaputra, Barak Valley, arsenic is again found in that. That gives you a pan-Himalaya scenario right from your Pakistan to your Barak Valley. Entire area gives you this arsenic. That means these sources of the arsenic is related to your tectonism. And as you know, Himalaya run east-west, and all the collision is like this, so erosions are like striking is north-south, so the impact is in the east-west, so the impact comes out, and all these due to the morphological slope, entire thing comes towards, maximum thing comes towards your Ganga, and something goes towards your Tibet. That's why Tibet is also affected with arsenic. So the basic thing is again can be explained by the well understanding of tectonism or structural geology. So there are some kind of calculation. The average discharge in West Bengal per well is 50 cubic meter per hour. If we pump it for 8 hours, you can get 4 lakh liter of water, and the number of people that you can serve with 70 liter per capita per day, so it is around near about 6,000 people. So one well can serve you for 6,000 people. In that way, you can calculate for a smaller township or smaller village how many well you want to construct deeper well. Similarly, in the Bihar part, the yield of water is much higher, double rather. It is 100 cubic meter per hour. If you do, it will give you 8 lakh liter, and you can serve almost 11,000 person per well. In UP also, it is in between, and you can serve it for some 8,000 people per well. So now, just to explain what happens in the dug well zone, in the dug well zone, as you can see, it is the top layer. Then comes your hand pump zone, and then comes your tube well zone. So these dug well zone, though in shallow, but doesn't have the arsenic contamination. Why? Or less toxicity. Because arsenic 3, when come in contact of oxygen, it converts to arsenic 5. And once it converts to arsenic 5, the toxicity reduced by 100 times. That's why the dug well zones are much more safer than your tube well or hand pump zone, or river water is having less contamination of arsenic than your groundwater. So what is faulty? I'm talking about a faulty well or well construction or good well construction. See, in that left side, if you do a normal well construction, all the red light, this area from red zone, which is arsenic rich, will give you water which go to your screen part, and where you are extracting water, it will mix with that portion and you will get a contaminated water due to faulty well design. But if you construct a well, good well with cement sealing, all those things, then that arsenic affected zone can be sealed out and only water from arsenic free zone can be obtained, and it will give you much good water. In Chhattisgarh, I have personally worked in Chhattisgarh hard rock terrain, apart from working in this Delhi NCR area. There we found the arsenic contamination is different in nature from the Ganga basin, because in Ganga basin the alluvial are responsible, the source is in alluvium, whereas in the Karnataka and Chhattisgarh the source rock is your igneous rock, and therefore the arsenic contamination is in situ. The rock are from there only and it gives to the aqueous phase. But here in Ganga basin, rocks are from Himalaya, get weathered, transported to your Ganga basin, and then the secondary thing give you that arsenic. But there, since it is the in situ, so the mechanism of elimination is simpler. What we found that all the arsenic contaminated rocks are acid igneous rock, and the acid igneous rock, as you know, granite is the plutonic variety and rhyolite is your volcanic variety, and another type is rhyolitic tuff, that is ash. So all these three rocks are having the arsenic content. If you eliminate these rocks, the chances of getting arsenic in well is less. And due to the north-south lineament, the hydrothermal solution which brought the arsenic or sulfide mineralization is along this north-south lineament. If you eliminate those linear fracture zones, then chances of getting arsenic is less. So one is your lineament, second is your acid rock. If you eliminate these two, chances of getting arsenic is reduced. Now what happens? There is a bimodal volcanism, there is a basic rock. If you identify simple geology, simple geological mapping, you just map the basic rocks and put your all wells in the basic rock, you will get less contaminated wells. And one very interesting thing found and has been confirmed in Ganga basin, if the electrical conductivity of water is more than 800, that is EC more than 800 microsiemens per centimeter, then arsenic concentration goes drastically down. So these solutions are so simple and it doesn't need much high-tech lab. Even with a pen type instrument, you can able to identify whether your water is having more than 800 EC or not. If water is more than 800 EC, it will say. If you test, you will find that there is no arsenic. And it has been confirmed. I'll show you some slides. So we have done some research in hard rock area and we have confirmed all what I have told you. So the geochemical, geological and structural control on arsenic availability on groundwater. So apply these controls, and by applying these controls, you can eliminate those areas which is supposed to have high arsenic. So if you see this, the all green portion is your basic rock, and by modal calculation it comes around 28% of the 10 kilometer radius. So this 28% area is safe from arsenic. And we have drilled so many wells in this and we got arsenic-free wells. But to come to this conclusion, we have to do some research. So why this? There is a chronology behind this. Everything has a, if you want to do study, you have to establish the sequence. Once you establish the sequence, people will believe on you. It is not that we have declared that drill in basic rock, you will get arsenic free, and people are getting. But scientific believing comes when you establish the entire sequence. So what happened? We have established the entire chronological sequence, why and how it eliminates. So the host rock in that area is banded iron formation and intruded by the batholithic intrusion. The people of geology student knows batholithic intrusions are granite, acid igneous rock, and every batholithic phase follows by a hydrothermal phase which brings you the sulfate mineralization all along the fracture. So primarily your batholithic rock means acid igneous rocks are the host for these hydrothermal solution. Now basic rock came later. Acid rock has been intruded by hydrothermal veins and has been contaminated by arsenic. When the basic rock came later, it has intruded through dome area and get secondary contamination in that and bit contaminated but not primarily contaminated. That's why in the basic rock you don't get that much concentration. So this is the sequence. You have to establish the geology, you have to establish the hydrogeology, then you can able to find this. In Ganga basin also we have proven that if you see 3000 EC, 0 arsenic, 4000 EC, 0 arsenic, 330 EC, 100 arsenic. 5 minutes. And now with 300 and 400 EC, you are getting arsenic of 10 ppb. And these are some simple engineering solution made by people like researchers. Simple 3-pot method or simple charcoal or this nail and brick and filter method. By putting through these, if you put the water gets 90% of arsenic get removed. Simple, if you don't want to do anything, take a new earthen pot. Store the water one night before and use it next morning. It will reduce 50% arsenic. So I am not going to much depth, and thanks for the cheat, sir.